Hey guys, welcome to Unit 5 Lesson 3. Our topic today is finding limits algebraically. So pause the video and try to do the warm-up on your own. It's a piecewise function. So let's start with this. A piecewise function is a function that is defined in pieces by two or more equations over a given domain. And we discussed that in Lesson 1 also. Let's review it again. So here this is your domain, means this function will be used for where x is greater than or equal to 1. The greater than or equal to symbol will give you a filled circle. So let's set up a table for this. This is x and y, right? So it's going to be greater than or equal to 1. So you're going to basically start at 1 and it's going to be a filled circle, right? Some of you can do this without the table. I'm fine with that as long as you have the right points and the right idea. I really don't care about it. So it's going to go 1, 2, 3, 4, and so on. And it is what? When x is 1, y is 3, 5, 7, 9. Those are the values you should get, right? For the second one, x is what? Less than, strictly less than 1. I'm going to make up that table here. X, y, it is less than 1, so the most you're going to go to is 1, and it's going to be an open circle. So this would be what? 1, 0, -1, -2, -3. So those are good values, and let's fill out the... So I filled out the table, and this is what your two graphs will look like, okay? So let's get started with the part 2 and 3, and we would need this graph for the same question. So f of -3. So what is f of f of -3? So I'm going to use actually the second function because x is -3 is less than 1. So it's going to be -3 square plus 3, which is 9 plus 3 is 12. F of 1, I'm going to use the first function because it has greater than or equal to. So this would be 2 times 1 is 2 plus 1 is 3. So it's going to be 3. And f of 5, which is also the first function, so 2 times 5 plus 1, which I get what? 11. Okay, so now I'm going to try to zoom in. Not really. Okay, so now this says limit as x approaches, the negative on top tells you left. Let's write that down. That's left. So as my limit is approaching from the left, I'm going to trace it. As x is approaching 1 from the left, where I wanted to use a highlighter. I'm approaching 1 from the left. What value am I approaching? Y value. It is 4. And then as I'm approaching one from the right, what y value is that? It is that y value, which is 3, right? Are these two same? They're not same. We know that. So limit as x approaches 1, f of x does not exist because they're not same. Okay, so that was our previous lessons. Now, how do we find limits? How do we work with this whole process? The 4-step process to solving limits problems algebraically. You always start with, if it's an equation, if it's graphs, you can just read it. If they're equations, you always try direct substitution. The only time you'll not try direct substitution is when you get a denominator of 0. So there's more to do it. So if direct substitution didn't work, which I mean is when you'll get the denominator of 0, right? Then you try to factor. See if you can factor and cancel out something, right? Try to simplify. If you have complex fractions, that's when you will be trying to simplify. That works when you have complex fractions. And if you have rational denominators, or numerators, try to rationalize. Here you will rationalize either the numerator or denominator depending on the question. So let's do some examples and then it'll make more sense. So for each of the following limits, so find each of the following limits. Okay, so as limit as x approaches -3. If I substitute -3 in here, look, if I do -3 plus 3, I get a 0 in the denominator, which is undefined, so I cannot do direct substitution. So what did we say? Try to factor it. Can I factor this? Yes, I can. So I'm going to rewrite it, limit as x approaches -3. So the numerator can be written as, it's the AM method. I need two numbers that add to 1 and multiply to -6. They are 3 and -2 over x plus 3. What happens is the x plus 3 cancels out, and what are you left with? I'm going to change colors. Limit as x approaches -3, you're left with x minus 2. And now do direct substitution. So -3 minus 2 is -5. So that's your answer, right? So we couldn't do direct substitution initially because you were getting the denominator of 0. So the next one is limit as h approaches 0. Again, this will make my denominator 0, so I can do direct substitution. So let's see if we can simplify this. So here I can, the numerator will become limit as h approaches 0, h squared minus 4h plus 4 minus 4 over h. The 4's cancel out. What are you left with? Can I factor out the h in the numerator? What will that do is it will cancel out with the h in the denominator. So I'm left with, and do substitution, so it's 0 minus 4, which is -4. Right, the last step is usually substitution after you cancel and everything. So now here you have a complex fraction. This is what I was trying to do. You can't apply the limit right away, because if you do, you'll get a denominator of 0, right? Or it won't work. So yes, you do get a denominator of 0. So what you do is, first of all, try to simplify the numerator. So take your LCM. So my LCM is 3x, and I get 3 minus x in the numerator over x minus 3. Do keep change flip. So what do I get? 3 minus x, I did write limit as x approaches 3. Limit as x approaches 3 over 3x times, this is, remember, over 1. So it's going to be 1 over x minus 3. So these are additive inverses. When you cancel them, there's a -1 there. So it's going to be limit as x approaches 3, I get -1 over 3x. Now do direct substitution. I get what? -1 over 9. Right? So here, D. Now if I substitute again, 0, I always have been saying that because I want you to be able to see that. If I substitute 0 for x, I get a denominator of 0, so this won't work. So what do? I'm going to rationalize the numerator. Remember, your terms are separated by plus and minus, so this is what you're going to change. So it's going to be, you're going to multiply and divide by the conjugate, right, over 3. It's the same terms, but it's the, you switch the sign, right? 9 minus x. Now be careful. Isn't this a minus b and this is a plus b? What is a minus b and a plus b? It is a squared minus b squared. That's what we're going to do. So this would be limit as x approaches 0. This would be 9 minus, I'm going to put that in parentheses, 9 minus x, the square root cancels out, right? Over, or you can just double distribute. If you are lost with that, then you can just double distribute it, right, over x times 3 plus square root of, you don't have to distribute that. Now what happens here is the 9's cancel out, right? And you're left with limit as x approaches 0, x over x times 3 plus 9 minus x. The x's also cancel out. So now apply the limit. So what are you left with? 1 over 3 plus square root of 9 minus 0 is just 3, which is 1 over 6. So that is your answer. So this is how you do each of, I did actually 4 questions with each of the kind. When direct substitution doesn't work, right, what can you do? Simplify them, factor them, or rationalize them, and then you do direct substitution in the end and find your limit. So finish up the problem set